In the last video, we went through a neat proof of Pythagoras Theorem using the method of similar triangles. In this video, we will look at a proof that is also very simple and perhaps more intuitive than the latter. It is a graphical approach that utilizes a minimum of equations. Welcome to the rearrangement proof. Here we have a right triangle, which is the only kind of triangle Pythagoras theorem works for. The normal convention is to name the catheti A and B and the hypotenuse C. For this proof to work, we will duplicate this triangle 3 times so that we end up with 4 triangles. It does not change the properties of the triangle theorem or anything else. Now we move these triangles in such a way that they form a square with a side length of A plus B. Now we copy this geometric figure. The reason for this will soon be apparent. If we take a look at the left figure, we see that the area of the inner square is C squared, because all of its sides are of length C. Now I just want to take a moment to remind you to like, subscribe and comment. This will help me to grow my channel so that I can produce more content like this. Also, if you subscribe and enable notifications, you will not have to worry about missing out on new content. Now let's take a look at the right figure. We begin moving one of its triangles towards its opposing triangle, so that it now forms a vertical rectangle, meaning that the rectangle is taller than its width. In the second step, we move another triangle towards its opposing triangle, thus forming a horizontal rectangle. Finally, we move the vertical rectangle down to the bottom of the square figure. In doing so, we can see that 2 new empty spaces have emerged. We can now identify a new square with a side length B, thus having the area of B squared. We also see a bigger square that has a side length A, thus this square gets the area A squared. Now let's have a look at both figures. Because we copied the square figure before, and we only moved the triangles inside the right figure, then both figures must have the same outer side lengths, which we denote by L. Thus the total area of both figures becomes L squared. If we look at the constituents of each square figure, we see that both consists of 4 equally shaped triangles each, because this was our starting point. Then we see that the remaining piece inside the left figure is a C squared square, and inside the right figure we have the 2 squares A squared and B squared. Because the total areas of both figures are identical, we can then put an equal sign between these 2 area equations that we just wrote. We now remove the triangles on both sides because they don't contribute to the equation. We finally end up with what we started with, namely C squared equals the sum of A squared and B squared. This is Pythagoras theorem, and thus the proof is complete.